If nitrogen gas is bubbled through water at 293 Kelvin, how many millimoles of nitrogen gas would dissolve in 1 liter? Assume that the nitrogen exerts a partial pressure of 0.987. Henry's law constant is given for nitrogen at 293 Kelvin is 76.48. So this problem is based on Henry's law. Take down Henry's law. So first of all, let us see what is Henry's law. The solubility of gas is related to the mole fraction in aqueous solution. That is, I have got this nitrogen. This nitrogen is passed through water. So to what extent it would have been dissolved? So the mole fraction of that nitrogen. The mole fraction, now here nitrogen is a solute, water is a solvent, is it not? So the nitrogen is dissolved in water. So this is the mole fraction. This mole fraction is proportional to the partial pressure of nitrogen. The partial pressure of nitrogen. Okay? The partial pressure of nitrogen. And here we introduce a constant. So chi2 is equal to 1 by kh, that is called Henry's constant, into partial pressure of nitrogen. Okay, so here you can simply put 2, P2, you can put P2, because we have taken this as solute. See, chi2 here is mole fraction of nitrogen. And P2 is partial pressure of nitrogen. Similarly, chi1 is partial pressure mole fraction of solvent, that is water. Okay, and we already know this chi2 is nothing but N2 divided by N1 plus N2. Okay, N2 divided by N1 plus N2. Here N2 is number of moles of nitrogen, here solute, number of moles of nitrogen, that is the solute, that is dissolved in water. N1 is number of moles of water, that being the solvent. Okay, right. Now this partial pressure is found to be 0.987, and this one is given in kilobar, so you can convert it into bar. So let us list out the given parameters. And what is asked? How many millimoles, that is asked. That is, molarity is asked in terms of millimoles. Molarity in terms of millimoles, I mean number of moles. Okay, this number of moles in terms of millimole it is asked. N2 is asked, that's all. In millimoles, right. Now the given parameter can be listed out here. So we know already chi2 is equal to 1 by kh into P2, and this chi2 is given as N2 by N1 plus N2. Therefore N2 by N1 plus N2 is equal to P2 by KH, or you will follow this K2 by P2 by KH, right? Okay. Now, in fact, as I already mentioned, the N2 is almost neglected here because it is very less. Okay. Anyway, let us proceed. So N2 divided by so let me rewrite N2 divided by, let me put N1, because being a dilute solution, N1 is much greater than N2 and N2 is neglected in the denominator on addition. See, you cannot neglect the N2 which is available in the numerator. So N1 plus N2 is equal to N1. Okay. For example, let me say this is 90 mole, this is 0.01 mole. So 90 plus 0.01 mole is 90.1. It is almost equal to 90. But 0.1 divided by 90 cannot be equated as such. And even 90 into 0.1. Okay, any small number cannot be neglected in multiplication and division. In addition and subtraction you can. For example, it will have drastic effect. 90 into 0.1 means it becomes 9. Whereas 90 plus 0.1 results 90 roughly. Okay, so during addition and subtraction of smallest that is units are allowed, but in multiplication and division it cannot be. Okay, right, because it will have greater impact. So N2 by N1 is equal to P2 by what? KH. So N2 is equal to P2 into N1 divided by KH. This is the final formula. Based on that we have to work out. Right? Okay. Now we have that is, let us consider what are the given parameters. Nitrogen gas is bubbled through 298 Kelvin. Nitrogen, okay, 1 liter. It is given as 1 liter. So water volume, it is given as volume of water, that is V2 is equal to 1 liter. So this is volume of water. Okay. And what about the other one? Exerts pressure. So partial pressure, this is V1. Volume of water means V1. Okay. Partial pressure P2, that is of the solute. What is P2? Partial pressure of the solute. So you have to mention what is P2. P2 is partial pressure of solute, in this case nitrogen. So V1 is volume of water, that is solvent. Okay, right. So P2 is given how much? 0.987 bar, and Henry's constant is given as 76.48 kilobar. So that is equal to 76.48 into 10 power 3 bar. Is it no? Okay. Now let us find out, and we need N1 here. We know P2, we know KH, we want to calculate N1. What is N1 actually? So this is KH. N1 is nothing but weight by molecular weight. Is it not? W1 divided by how much? M1, molar mass of solute. W, it is taken as 1000 gram in this case. Do you know why? Because 1000 liter, 1000 ml. 1 liter means it is given as 1 liter, that is 1000 ml. 1000 ml of water will be equal to 1000 gram of water, because the specificity is 1. Therefore 1000 gram divided by, what is the molarity of molar mass of water? Molar mass of water is 18 gram per mole. So 18 gram per mole. So first of all, let us calculate this N1 of 1 liter of water. So 1000 divided by 18 is equal to 55. So 55.5 into 10 power 3. Not 10 power 3, 55, that's all. Okay, so 55.5 mole. Mole inverse. Not mole inverse, mole. Because this is mole inverse. Gram per mole, so this is mole. So what is the mole of 1 liter of water? 55.5 mole. So this is the standard value, you should note down. But I have worked out here. Okay, right, now let us substitute everything here. So N2 is equal to, what is N2 here? P2. What is P2? 0.987. So 0.987 divided by into N1, 55.55. 0.5 divided by how much? KH, 76.48 into 10 cube. 76.48 into 10 cube. So that is equal to 0.987 into 55.5 divided by 76.48 into 10 power minus 3. So that is equal to, now let us work out, 55.5 into 0.987 divided by 76.48, 0.7162. So 0.7162 into 10 power minus 3, and this is mole. Okay, so what is asked here? Millimole. So this is called millimole. 10 power minus 3 means millimole. So the answer is 0.7162 milli, because milli means 10 power minus 3, and mole. Okay, so this is the what? The number of moles of nitrogen. Okay, answer. Right, so let me recap once again. Nitrogen gas is bubbled and water is the solvent. Nitrogen is the solute at 293 Kelvin. It's not necessary that you should use all the parameters given in the problem. This is as a standard value they will give in the certain temperature. So, and it is asked how many millimoles of nitrogen. So for solute is asked. So that is why I put N2 is equal to 1. Would dissolve in 1 liter. So the volume of water is 1 liter. Assume that the nitrogen exists. So its partial pressure is given as 70.98 and Henry's constant is 76.48. So this is the Henry's law, and based on that we have worked out, and finally that is N2 by N1 is equal to P2 by KH. N2 is equal to, this is a formula we applied. Substituting all these values, we are able to get. And you should note down 1 liter of water has 55.5 mole. So this can be worked out based on this formula. Okay, so this is very important. And finally, by substituting all this, we will get 10 power minus 3 mole. But in the question it is asked as millimole. So you can put millimole. Okay, excluding this 10 power minus 3. Right?